Welcome to today's webinar. We're going to be talking and going through TDengine Cloud. My name is Sean Ely. I am the head of product at TDengine. Okay, so a little bit background about TDengine. So TDengine Core is fully open sourced. The single node edition was first open sourced in July of 2019. Clustering came out in August of 2020, and our cloud native edition was recently released in August of 2022. You can check out our source code at GitHub for TDengine, and we're very popular with 19,450 stars, over 4,500 forks, and over 16,000 issues. And we have about 158,000 running instances in over 50 countries. Some of the main advantages of TDengine is its high performance, it's really fast, and it scales. It's open source, so the core TDengine time series database is all open source, including clustering. It is a simplified solution, so TDengine has not only a time series database, it also has caching, subscriptions, stream processing to handle your real-time data needs. Ease of use, so very easy to get started, easy to get data in, easy to get data out. We use SQL as our querying language, so there's no learning curve for any developer who knows SQL. It's cloud native, it's fully cloud native. In our most recent release, including the open source version, and easy data analytics. So we have many popular programming connectors so that you can get access to your data and use it the way you want to use it. So TDengine Cloud is our recent offering. It's a serverless, fully managed cloud offering from TDengine, and I'll be demoing it today. The main features of TDengine Cloud is a simplified setup and management. It is a high-performance database, and as I mentioned, it has built-in caching, stream processing, and data subscriptions. And TDengine dramatically reduces the tools needed to start, operate, and manage time series data at scale. TDengine Cloud is free to try. So I'll show the use of it in this demo, and please sign up and try it. Fast and easy data ingestion. So with SQL and the popular programming language connectors, it's very easy to get data in, and it's very fast at ingesting data. We also have seamless integrations with data collection agents, and you can also insert data using schemaless protocols. Easier data analytics and sharing. So developers can access, subscribe, analyze data from our platform. We also have edge to cloud and cloud to cloud synchronization that can replicate data to wherever you need it. TDengine Cloud is enterprise ready. It's got robust backup, multi-cloud replication, unlimited users, user privilege controls, VPC peering, IP whitelisting, and we provide professional technical support. Okay, so I will now jump into TDengine Cloud and show you the interface. So when you first create an account, it's going to set up a cluster. Right now it's starting an interface. We host on the 3 major cloud providers. So we have AWS, Google Cloud Platform, and Azure. I have created an instance on AWS US West 2. And so when you register for the first time, you will see this kind of tutorial to kind of explain the main concepts of TDengine. So walking through these, TDengine is a time series database. It stores time series data, which we call metrics here. And so this is for a kind of typical smart meter type application in which we're measuring current, voltage, and phase. So these are numerics for measuring data, and then every measurement has a timestamp associated with it. It's kind of a Unix timestamp, but you can also have the date and time format. With the measured data, we also have metadata or labels. We call them tags. And so the tags are not time series data. They're not changing over time. This is your static data. And so each table would have some static data associated with it. And this can be, say, like your location, a group ID, maybe it's like a part number, whatever you would need to find your data, filter your data, kind of group and perform aggregates on it. And so this data, when you're looking at your data, you can look through these tag data and use it just like it's a column, a metric, a time series data, but it's static. It doesn't change over time. One of the key concepts of using TDengine is that each device has its own table, and you determine the table based on what we call a data collection point. And so it's all metrics measured at the same interval. And so for these time series, for these smart meter metrics, they all measure these three values, current, voltage, and phase, at the same time. And so each time a measurement's taken, a new row is added to the database. All that data is added to tables, and it's added per device. So if you had a smart meter in, say, San Francisco that was measuring data, it would have its own table associated with it. If you had a second smart meter in San Francisco, it would have its own table. And so you're going to have a lot of tables in your database for all the different devices that are measuring data. With all those different devices measuring data, it's important to have a way to aggregate that and organize it so that you can easily find your data and find the data you're looking for. So we created a concept called a super table. And a super table is a template for creating tables. And it creates the schema for the tables, the subtables that belong to it. And so for the smart meter example, it's got timestamp, current, voltage, and phase. And then you're also defining the tags, the metadata associated with it. So it's got location and group ID. And so the super table does not hold any data itself. It just is the template or the schema for all the subtables underneath it. The super table can be used both as a template and as a way of kind of querying individual tables. And so you can query the super table to get all the individual results underneath it. As I mentioned, the subtables are tables created from a super table, and they have measurements, metric data associated with it, as well as tags, the metadata assigned to it. All these tables reside in a database, typical architecture for, and the last item to add is, so TDengine is a kind of fully distributed database. It has clusters associated with it, and we call these clusters in the cloud platform instances. And so right now I've got an instance named Sandbox. And then the instance has databases and tables associated with it. In order to access an instance, we use a REST API, and it's got a URL and a token. So walking through the cloud platform, we've got a DevOps dashboard, which shows uptime, kind of your metrics around ingress, egress, storage, how many queries have been run, and how many inserts have been run. Not much activity with this kind of demo database, but walking through, we've got our different connectors listed on our data in page. And so we've got Java, Go, Python, Node.js, C#, Rust, and then just a general kind of REST API connection. So I am a Python developer, so we look in Python. You can see we've got a package that's available through pip. So you can install TauSpy, and then in order to connect to our cloud instance, you just need a token and a URL, which have been provided here. And we've got a connection. So you just set up the connection with the token and URL. And from there, you can start developing with it. So I'm going to move. Okay, restarting my instance. Okay, so moving on to Explorer. I've got two databases here. If you look at a database, it has all the kind of the configuration set up for it. And you can look at a subtable or a super table, excuse me, in which you've got your columns here, timestamp, current, voltage, phase, as well as the group ID and location. So this is one I created in which I was inserting data using Python. If you click on a table, you can see you've got your timestamp, all the values associated with it that show up. You can also use SQL to get the same data. So if I did a select star from, this is demo.meter1, limit 200. Now I can run that query. It's going to give me the same data. So anything you can do in SQL, you can put into the Explorer interface in order to query data, do analytics. We also have a charting feature. So if I want to do a line chart, I can do current, voltage, and phase, draw those values, and you can see them. We also have favorites. So if I wanted to run this again, I can just add it to favorites. And so at any time, if I say want to go back to it, I can just select my favorite, run it, and see that data again. And we have logging for all the queries you've run. Looking through here, it shows you the kind of what's in that table. You can also select it. I see that the values I have are, it's group 1, it's California and San Diego, this meter is where it's located. Continue walking through the UI. We've got data out. And so in the data out section, we've got the same kind of connectors you can use to connect. We also have Taos dump, so you can do data backups, writing a table, portion of a table, or a super table to a file. We also have data subscriptions, which are shown here in the topics. So I don't have any data subscriptions set up. However, you can set up data subscriptions and you can publish data, updated data to any consumers consuming that data. Going back up, we've got third-party visualization integrations. So we've got Grafana and Google Data Studio. And if you say clicked on Grafana, it's got instructions on how to install the plugin, the official plugin, and connect up your Grafana instance to TDengine Cloud. We have stream processing available as well. And so you can create a continuous query which is running on your data. It can run either when data is updated, or it can run based on kind of time intervals. So you could say, maybe every 10 minutes, I want to perform some calculations on my data, write it to a new table, and we can do that in real-time data processing. There's some tools here for connecting to the command line interface, as well as a benchmarking tool. And network, we've got, you can add a VPC and monitor traffic. You can look at instances and create new instances, as I mentioned, on the 3 major cloud platforms. When you create an instance, you can also have a database with 1 million data points created, a demo database. And you can select between our free plan, standard plan, and you can contact us if you're interested in the enterprise plan. We also have user management, which I don't have set up on this demo account, but you can add users, give them permissions and roles, and invite people to your organization to share data. And that covers it in terms of a quick overview of TDengine Cloud.
Sean, may you talk a little bit more about the registration process?
Absolutely.
You log out, explain how to register how easy to register for this account.
Yeah. So I've logged out. So we have the option of connecting through GitHub, kind of Microsoft or Google type connections, or let's do create an account. Yes, so you can connect with one of these third-party authentications, or you can enter your name, email, and get a confirmation code to sign up. When you sign up, there's no credit card required. So you can get started right away using our free account to start exploring and working with TDengine Cloud. Yeah.
Okay, that's great. Okay, it's great. So, okay, pretty good.
Okay.
I think maybe people can ask questions in Discord channel, or so or everybody are welcome to join our Discord channel to ask questions. Sean and I and all our team can answer those questions online. Okay.
Absolutely. Okay. Yes. Please join our Discord channel. Happy to connect with you and answer any questions.